Lesson 7.7, the determinants of a square matrix. What we're going to talk about is a determinant, and a determinant is a number value that is associated with a square matrix. So again, notice determinants are strictly for square matrices. You will not have a determinant for a matrix that's not square. The way you find the determinant of a 2 by 2 matrix is you can write det A and then you use the parallel lines. Notice that you're going to use parallel bars instead of brackets. If you use brackets, you're not talking about a determinant. So when you see parallel bars around a matrix, that means you're looking for its determinant. And what you're going to do is take the product of the main diagonal minus the product of the other diagonal, which was part of when we found the inverse of a 2 by 2. So for example, we would like to find the determinant of this matrix. So that's what these parallel bars mean. So we're just going to write the product of the main diagonal. You always start right here. 3 times 5 minus 2 times negative 6. So we have 15 plus 12, which is equal to 27. If you take this diagonal, the product of this diagonal minus this one, you're going to have this, the sign is going to be wrong. So it's extremely important that you always do the product of the main diagonal minus the product of the other diagonal. So this is what I just mentioned. The formula for finding the inverse of a 2 by 2 matrix, this part of it right here is what you're doing. You're going 1 over the determinant of the matrix. So we're saying 1 over the determinant of the matrix times the matrix. This part here, remember, was not the determinant. This was just telling you you're multiplying by some matrix, or the original. Not the original. It's when you flip the first and fourth, negated the second, third. In other words, so this is not a determinant here. This is the only determinant piece of the inverse. Now, determinant of 3 by 3, I am well aware of the fact that your calculator can do it, but I want to show you how it's done. This process is called expanding by cofactors. So the determinant comes from the sum of each element in any row or column of A multiplied by their cofactors. And let me explain a little bit more. When you find the determinant of a 3 by 3, the first thing you want to do is find a row that has zeros in it, but we'll get to that in a minute. This is the chart you're going to use. In other words, we're going to go plus minus plus, minus plus minus, plus minus plus. Plus means you're going to keep the sign the same. Minus means you're going to flip it. This will all make sense once I start putting this together for you. So, for example, minors and cofactors. Minor is just when you circle any entry, eliminate that row and column, and then the minor is the determinant of what's left. So, for example, I want M22. So that means I'm going to take the second row and the second column. And I'm going to cross off anything that's not in that second row or column. So we have this. Actually, I'm going to cross off everything in that row or column. So we're going to cross off the second row, second column. So we're going to find that go 1, negative 2, 1, and 0. And then that determinant will just be 0 minus negative 2 or 2. Okay, let's do it for 2, 3. So that means we're going to eliminate the second row, eliminate the third column, and then take the determinant of what is left behind. So 1, 3, 1, 2. So this becomes 2 minus 3, which is equal to negative 1. So the minor is the determinant of what's left after you've crossed off that row and column. We're going to put this all together between finding the minors and using the signs of the numbers that are left. Now, cofactors are the product of the minor and the correct plus or minus sign. So for example, the chart that I just had on that first page went like this. It went plus, minus, plus, minus, plus, minus, plus, minus, plus. So remember, plus means keep the sign the same sign. Minus means you're going to flip it. You're going to flip the sign. Okay, so instead of doing dashes, we're just going to draw arrows. So for example, we want for C22, we want the correct sign plus times the element 1 times the minor for the second row. In other words, so here is we're going to combine the last page with what I showed you on the first page. So here we want 2, 2. So here's the second row and second column. I'm going to eliminate the second row, the second column. So I'm going to write out 1, negative 2, 1, and 0. This is just what I did on the previous page. We're going to change one thing, 0 minus negative 2 And so it looks like this equals 2. Now notice on my chart here, for second row, second column, there's a plus. That means I have to put a plus in front here. So whatever I do to the final sign, I got to keep it the same. So this stays plus 2. So this was for 2, 2. And now we're going to do C, 2, 3. So now we're going to take the second row, third column. So back here, if you look, second row, third column, we ended up with -1. I'm just showing you what I have back here because it'll be less messy. We ended up with -1. However, second row, third column, we have a negative here. So even though, according to this, I ended up with -1, because the sign chart says I have to do a negative here, we're going to go negative, -1, and the answer is +1. Okay? So here I didn't have to change the sign. Back here I ended up with a +2, and because I'm dealing with the element in the second row, second column, there's a plus here. That means I keep the sign the same. So this stays +2. However, when I did this one, when we had C2, 3, the number we got from the previous page was a -1 right here. That's what we got. And in the second row, third column is a negative. So that means I take whatever this sign was and flip it. So -1 becomes +1. Now, we're going to put all this together. And just a hint again, look for zeros when calculating the determinant of your 3 by 3 matrix. So we want to find the determinant of the following matrix. So first thing you want to do is pick a row. Since this, I can either go first or third row. I mean, I can go first, second, or third, but the first and third rows have zeros, which makes my life a whole lot easier. So first thing I'm going to do is, if you remember that chart, the top row went plus, minus, plus. So what I'm going to do is I'm going to go +0, like this, and then I'm going to go -2, and then like this, and then +1, and then like this. So now, if we take the 0, I'm going to eliminate everything in this row and this column, the first row and the first column, and I'm going to have -1, 2, 0, and 1 left. Now I take this 2 right here. I'm going to cross off that row and that column. So now I'm going to have 3, 4, 2, and 1. And then the 1 right here, I'm going to cross off that row and that column, and I'm going to end up with 3, -1, 4, and 0. So now we're going to go 0 times -1 minus 0. Well, that's not going to matter. This is all going to turn into one big 0. Minus 2 times 3 minus 8 plus 1 times 0 minus -4. So now we have 0 minus 2 times -5 plus 1 times 4, and this turns out to be 10 plus 4, or 14. That's the determinant of the 3 by 3 matrix. Now let's say you'd pick the second row instead. Now that second row would have been associated with negative plus negative. So you would have gone -3, crossed everything off in that column and that row, and written 2, 1, 0, run. And then we would have taken, so we have -3, -1 is right here. There's a plus here, so that means I don't flip the sign. You cross off the numbers in this column and this row, and you would have had 0, 1, 4, and 1. And then you would have had -2. Cross off all the numbers in this column and this row, you would have had 0, 2, 4, and 0 left, and all this wonderful magic. You would have gotten the exact same answer. And the same thing if you pick this row too. That row is associated with plus, minus, plus. Then you would have made this +4, leave this 0 is not going to matter, and +1. You eliminate this column in that row with the 4. Write these numbers in your determinant. Here you have the 0, cross off this row and this column. It doesn't matter because you're going to go 0 times it. And then we have the +1 here. Cross off this row and this column. You'd have these 4 numbers left, and all your magic. Again, you would have ended up with 14. If you get different numbers, you made a mistake. Okay, I know this seems confusing, but once you practice it on your own once or twice, it does get easier, I promise. Now, when you try to evaluate determinants of matrices of order 4 or higher without a calculator, it gets difficult. However, the one exception is when you deal with a triangular matrix. A triangular matrix is a square matrix with either zeros all above the main diagonal and numbers everywhere else, or vice versa. So in other words, if you wanted to, and the way you find the determinant is you just multiply the numbers on the main diagonal. That's all you have to do. So notice this is a triangular matrix right here because it fits the bill. It has zeros above the main diagonal, could have had zeros below or instead, and then numbers everywhere else. And the way you find the determinant is we're going to go 2 times 3 times negative 2 times 3, and you would have ended up with 6 times negative 2 is negative 12, times 3 is negative 36. There you go. And notice I knew I had to find the determinant because they're parallel bars here. So if there were brackets here, I would have no idea what they were asking for. It would just be showing me a matrix. Now, for a homework hint, just fun 53, the answer is a quadratic equation that will not be factorable. Use the quadratic formula and just leave in simplest radical form. Don't deal with messy